Hello and welcome to another video from Flash Jazz Cat. On the desk in front of me here I have an Atari 800XL motherboard, which is more or less par for the course these days. But it's an interesting one because it's been sent here actually already with a very interesting device called the GTIA Digitizer. Now the reason it was sent here was twofold. The owner wanted the Ultimate 1MB installed, but he also wanted me to sort of tidy up the GTIA Digitizer installation, which I haven't done yet. I've decided to leave that as the subject of the video basically, because he'd used the clips which I've got here, just hooked up anyway, going straight to the connector in the old RF modulator here. Now if I show you from above what I've actually done, I'll unhook all this. This is the RGB to HDMI, which I'm also going to cover in this video. But let's take everything apart and I'll show you what's what. But before we do that, a word from our sponsor, PCBWay. Now, as well as offering PCB prototyping and assembly services, they also do CNC machining, 3D printing, and they'll even print you a flexible PCB. Not to mention sheet metal services and injection molding. So really they're a one-stop shop, whatever your manufacturing needs happen to be. And of course they also happen to be extremely helpful and one of the nicest group of people you're ever likely to meet. So what have you got to lose? So if you need a prototype PCB or any of the other services I've just mentioned, why not do yourself a favour and pop down to PCBWay today. So the idea of the GTIA Digitizer is to emit what's known as Luma code, which comes through the red wire here, and that is an easy way to get, well, it's not, it's a little bit convoluted actually, because it's a proprietary video format of sorts, but without doing any, well, barely any modifications to the computer, and none to the case whatsoever, you can get this Luma code digital video signal out of the back of the machine. This green wire is just a ground, so we've just got that hooked up to the CAN, but this red one is going to the center pin of the RF connector here. Now, I don't know exactly what the owner's doing for audio. I'll have to ask him about that actually. I should drop him a line. I'm assuming he's going to take it from just a custom cable here. I might have actually said that I was going to make him one, so that, if that's the case, we'll do that before we ship the machine back. But I'm primarily interested in the video side of things. Yeah, I'm going to unhook this just because I want to show you what I've actually done to the RF modulator here. So this is the GitHub page for the GTIA Digitizer project. This is by Copper Dragon. So it says the GTIA Digitizer is a small board to be used in an Atari 8-bit machine to create a Luma code video signal by sniffing the relevant signals inside the machine and recreating the intended video output. So it's a purely digital solution. Here's a picture of the mod kit. So although you can't really see it in the overhead view of the board, this is what's underneath the GTIA chip. Just this small board here, and obviously you get the clips with it, which is what the machine's owner used. And you get an installation guide. So you take out the GTIA chip. Obviously you might have to put a socket in if there isn't already one there, which would probably be the most challenging part of the whole procedure for many people. I see he's got Micron DRAMs on the board there. Well, you might want to get rid of them. But anyway, so there's the board, and you use the cable to attach it to the RCA jack, or the obsolete RF output port. As you can see, the person who wrote the guide, he's cut a hole in the top of the CAN, pretty much the same way as the machine's owner did. We're going to change that. When directly using the clips for a solderless install, you may have to leave the lid of the RF CAN open. So so he basically drilled a hole or cut a hole in the top of it. The new output signal is not directly usable with a TV or a monitor. So you won't find a monitor out there which actually is able to decode Luma code out the box without something in between it and the machine. You need a compatible upscaler to create HDMI. One possibility is the RGB to HDMI with analog input. And there's a bit of blurb at the bottom there about the colour signal the Atari actually produces and how the digital signal is put together. Now if you want one of these things, there's a place called Tindy which actually sells them. They're $39. You may be able to get these from other places, but this is the link that was in the topic on the Atari Age forum. Again, it goes into detail about what it actually does. So that's it really. If you want one, it's $39, but watch the rest of the video before you decide whether you want one or not. So what the owner did is he'd left the contents of the RF modulator in, and he could get to this pin. So he just hooked up the red clip onto this one and picked a ground point for the green one. Now he cut a hole in the top of the RF modulator lid, a square hole down here, and he ran the wires in through there and he put the lid back on. As I say, I've took that off and I've thrown it away now, so I can't really show it to you. So he asked me if I could do a bit of a tidier job. So what I thought I would do here is actually gut the RF modulator completely. So take the circuit board out of it. We should be able to run, say, the red wire through one of the little grommeted holes here where the old connections from the video circuit used to go in, and just run that along to there, and that should work out perfectly fine. And we'll just take this green wire to a ground point somewhere, so that should work out fine. But of course, taking the circuit board out of an RF modulator isn't quite as easy as I thought it would be. You have to go at it from the underside, so I had to take the can off the board because you can't get the circuit board out the top. I took the top off, but you can't get the board out that way. It's impeded by these little push outs here. I don't know what you call them anyway. The lugs of sorts. They keep the board from coming out the top. So you have to take the whole can off the board by desoldering the lugs on the bottom, if you're not familiar with that. I'm talking about these here, the lugs there, and there. You have to desolder them, lift the whole RF modulator out, and then fight the bottom of the can off, because the bottom comes off as well. It's much like this one, but it's got slots cut out for the little lugs to come through. And then the RF modulator board itself is soldered at 5 different points, I think, directly to the chassis of the RF modulator, which is fairly thick metal. So you need quite a powerful iron to wick all that solder away. And then you have to get in there with a screwdriver and lever the damn thing out without bending the thing out to shape. Eventually I got it sorted anyway, and then I put the bottom back on, soldered the thing back to the board. So this is going to look totally stuck when it's put all back together, from the outside anyway. And I found a spare, it's got a couple of rust spots on it, but it's in no worse shape than the original one was. I found a spare lid for the RF modulator, and we can even put the lid back on when we're done. So all we'll see is this little red wire going in here. The chassis is going to be directly connected to ground on the machine anyway. You could just as well run the ground wire to anywhere on the board actually. But anyway, I'll go over the RGB to HDMI itself a little bit later on in the video, after we've got things wired up here. Right, so we can hardwire these two wires in. We'll feed them through these two holes here. I mean, with this detachable cable, you'll still be able to remove the GTIA digitizer from the machine if you want to. So let's go ahead and do that. The only thing that I'm a little bit concerned about is if the wires will actually fit through those little holes. Maybe they won't. I might have to drill them out a bit actually. Right, so I'm just going to snip these off. They're going to be long enough. And we'll see if we can feed them through here. I've got a feeling they won't fit. I mean, I could use thinner wire, but I don't really want to. Yes, I think I'll drill them out a little bit. I'll be back in a minute. Right, that's better. Just drilled them out a little bit. It had to be a bit of an angle because of the way the drill was, but they fit through the holes quite nicely now. I think we can make them a bit shorter actually. Yes, we'll make them a bit shorter. Right, I think we should just be able to put the ground wire down here. Right, that looks okay. And now we can put the lid on. And that's it. you'd barely know anybody had ever been in there. So that's that pretty much done. I'll turn the iron off, I'll put the machine back in the case and we'll give it a little spin. Right, so the case is back together now. We'll hook up the Lumacode. HDMI cable's already in, so we just need to pop the... So as you can see, nothing to see at the back, just a bog standard RF jack. So the RGB to HDMI, it's already powered up. It needs a power supply. It's got a USB, is it USB-C or micro USB connector. Always nice to have some of them floating around still. So I've just got it powered off the PC. The HDMI cable is mini HDMI or micro HDMI, I forget which, same as the type you'd find on a Raspberry Pi. So I bought one of them because the owner didn't send one up, but it's going to be worth having anyway. So let's get the monitor turned on, get the camera adjusted. So if we press the SW1 button, we get this menu here. SW2 goes down over, SW3 goes up, and SW1 again selects the option that you've got. So I'll turn the machine on anyway, so we can see what we've got. Get rid of this menu. So if we go into the Ultimate 1 MB setup menu, you can get an idea of how nice and sharp things are. I'll get the camera in a bit closer so you can see. Right, so I brought the camera in for a bit of a closer shot there, so hopefully you can appreciate how nice and sharp things look. Now the only thing I found when I turned the thing on, it's not really very apparent on camera, unfortunately. To my eyes it certainly is that it just looks a bit dark. That blue background just looks a bit on the dark side. And I have faffed around with the brightness controls on the monitor, etc., just in case it was that. Obviously we're coming through the HDMI port. This particular TV has some sort of sharpening algorithm on it, which you can't completely disable. Like a PC, if you plug it into the HDMI port on this machine, is just absolutely awful. But nevertheless, I don't think that's got anything to do with it. I've faffed on with the brightness, the backlight, etc. And if you compare this to a VBXE machine, for example, the VBXE, the blue background is much brighter. Likewise, when we go in here, the grey, the differential between the white and the grey in this menu, as I say, it's not particularly apparent on screen, which is kind of frustrating, it seems to be more emphasised with the Lumacode solution than it does with, say, a VBXE or even a stock machine. Now, having said that, I'm not blaming Lumacode for this, or I'm not really trying to nitpick, but this is just an observation. Now, this might not be the fault of Lumacode per se. This might actually be the palette that's built into the RGB to HDMI. If we go into the menu here, I don't know much about this device, but if we go into the menu and we go down to palette menu, I've been through them all. I can't say anything else that looks remotely relevant. So as we can see, we've got the Atari 800 PAL palette. Brightness is already on 100, contrast's on 100. I would like to see actually VBXE going through the RGB to HDMI just to see what it looks like. Now that would be interesting, so we could compare and contrast the two. But it is, without any doubt at all, it is tremendously sharp, and I can see why people have been raving about this solution. As I say, not least because it's so easy to install. It's even easier to fit than, say, Sophia, and it doesn't affect the external appearance of the machine in any way, shape or form. So I'm going to check to see if the owner wants a cable made up for audio. If I had an adapter, an RCA to 3.5mm adapter, I could have actually used this video cable, this one here, to plug the audio into the input on the back of the TV, which overrides the HDMI digital input, of which there is none, of course. Oh, we've got a screen capture function as well, which I've just accidentally hit. That's quite interesting. I'll tell you what I'll do. I'll capture a couple of screenshots, and then I'll overlay them on the video and we'll actually see what the colour looks like. So I'll capture that one, and then we'll go into the self-test, and I'll capture that one. You see, that looks dark to me. Clarity-wise, it's the absolute equal of Sophia. Now Sophia is most commonly, when I get them to install, it's most commonly they want to use DVI out with the supplied Sophia DVI adapter. It's not so often that somebody buys a Sophia and they want 15 kilohertz RGB out or component, although the Sophia 2 will do all of those things. It'll do VGA as well. If all you want is crystal clear video, and you've got an RGB to HDMI that's been suitably modded, or you're prepared to get one, it's an absolute no-brainer, especially if you're not keen on having the back of the case cut open. But the one thing to remember, of course, is that as far as I know, this solution, like DVI video from the Sophia board, is not going to give you those PAL blending effects. I mean, let's check. It actually, well, it might emulate them. Let's have a look. Yeah, we've got, right, here we go. We've got artifact color off. So let's turn that on and see what that does, if it does anything at all. We've got NTSC, phase, type, quality, PAL, odd, even line, blended colors. Right, well, let's try a demo. Right, so what I've decided to do here, rather than just messing around running demos on one thing and the other, is do a side-by-side test here, to see, or just give an impression. This isn't going to be a definitive test, but just to give an impression of how authentic the output is from the RGB to HDMI through the GTIE digitizer, because I want to know if this is a legitimate total replacement for the onboard video. So I've got the Side 3 loader running obviously on both displays. So now this one on the left is the legacy display. So this is S video or YC video through the legacy video port. This 800XL, it's basically got stock video. It's had C56 removed and it's had the chroma connected, and of course it also has GTIE digitizer. So this one here, the monitor on the right, is the HDMI output through the RGB to HDMI via the GTIE digitizer. So you can see there's a different, you're going to have some screen and panel variation and that kind of thing. I don't know how well this is going to come across. I'll try and make it so that it's reasonably detailed. But anyway, what we're going to do is we're going to run the base 33 demo initially, and we'll get sound from the left monitor because that one's got the audio hooked up. So here we go. So I'm just going to run it. I'll edit it a bit in after the fact so that we just focus on the areas of interest. But here we go anyway. What I can tell you straight off the bat here, I might as well narrate in real time here. I'm not sure what mode's actually used for the colour pictures in the demo. On the original video output, so this is being decoded by the TV directly, S-video, there is less flicker, but the scan lines are more pronounced. So that's on that earlier slideshow colour pictures. There's less flicker, scan lines more pronounced. On the other one, the scan lines were less pronounced, but it was more flickery. Right, so here you go. So we've got far more pronounced scan lines here, and more flicker on this picture. So it's definitely different. I suppose the main thing is that you get all the colours. This might actually be preferable to some people, but that looks more, it somehow looks more authentic. If I had the time, because a lot of the stuff's still in storage, I would get a CRT monitor out and show you the difference there. But at least in this case, we've got two like-for-like monitors. You can at least get some kind of impression of how things look. This particular mode looks identical, no difference that I can see. Same here. There's no difference here. I don't know if is this any point, any colour, or some sort of graphics 10 variant. It works, but it's different. But I'm sure you can tweak the RGB to HDMI to your liking. I mean, I'm very, very impressed I don't think you could complain too much if you were watching all these demos through this. I don't think you would have too much reason to complain. One thing I do want to try is interlace. So I've got Rybags 480 interlace mode somewhere here. Is memo pad. Right, let's try this. Now this doesn't work so well at all. Yeah, that looks terrible. That must be why it's flickering more. So yeah, that interlace display is not nice on the RGB to HDMI, and it's rock steady on this TV through S-Video. Absolutely spot on. It's not even flickering to the eye, and this is only 50 Hz. It's flickery and it's blocky, and it just doesn't give the interlaced effect. I don't know if that's got anything to do with the colour blending. So if we try and turn the colour blending off, yeah, nothing. The PAL odd line setting, no PAL odd line setting makes this look any better. Yeah, it's not doing a good job with interlace, in my opinion, at all. We'll try a couple of other things anyway. I've got a HIP demo. Right, so yeah, so far more pronounced scan lines here, which gives the impression, it sort of gives the impression of more detail. This, it's much more flickery. It's smoother. The gradients are a lot smoother, but it's pulsating. It's flickery. So I'll have to look into the graphics mode HIP. I'm assuming it does have an interlace element to it, but you wouldn't be able to tell from looking at this. Notice that we've got some crap over on the right hand side here, which we do not have here. Other than that, this, I'm far more comfortable with this, to be honest. This just happens to be an excellent TV for this kind of thing. There's nothing I can throw at it that it doesn't like. It does all the interlace modes, it does the 480i modes, anything, everything. I wish I had more of them. I've got two this size and a smaller one, but if I see another one, I'm buying it. And I like the sort of trueness of being able to see everything, all the scan lines and all the pixels. This is smoother. It's obviously, you can see it's kind of interpolated, but yeah, I mean, it's doing a reasonable job anyway. From a distance, you probably have nothing to complain about. And if this was the only way you could get the computer connected to the TV, I don't think you would be too unhappy with it. But as is always the case, if you can find a monitor like this with an S-Video input that's as tolerant and faithful to an old computer video signal like this one, yeah, it's not as razor sharp as this is, probably not quite as saturated as this is, but it's giving you a completely true representation of the original video characteristics. And if you get this one, as a reminder, it's an LG M227WD. If you get one of these and the screen's still in decent condition, you can buy new panels for them. I think I replaced the panel in this one because I scratched it by accident, the old one. So you can replace the panel. The only problem is they're a complete pig to try and disassemble. They've got clips all the way around the outside of the fascia, the bezel. You are going to break the clips, some of them, certainly, when you take it apart. It's a right pain to take it to bits. But this is a brand new panel in this monitor. I hope it goes on and on and on forever. So this is going to give you far more flexibility with the display device. Anything with an HDMI input on it, it's going to work. So if that's a factor, and it probably is for a lot of people, certainly is for a lot of people who aren't in the UK or Europe, where we have a lot of S-Video and SCART-enabled TVs, certainly going to be a factor. And in normal day-to-day use, as long as you're not looking at strange software graphics modes that rely on interlacing and all that sort of stuff and color blending, you're not gonna notice any difference. But the legacy video output with a suitable display offers a truer, a more authentic experience. This isn't quite there yet, but it's very, very good. I'd appreciate your comments actually from somebody who actually knows more about RGB to HDMI, specifically with reference to the Atari, about how well it actually handles this PAL blending effect for these multicolour software modes. So this RGB to HDMI does appear to be making some sort of effort at doing PAL color blending. Most of the time when you install VBXE or Sophia, Sophia being a good example, Sophia does not emulate that kind of color blending, PAL color blending at all. And now if this is capable of doing that, you've got a more or less perfect crystal clear video solution for somebody who doesn't want to alter the outward appearance of the machine. I mean, you could take this, the wiring that I've done inside the RF modulator, because nobody really wants to use the RF modulator now. Well, probably a few die-hard nostalgia fans do, but this machine could be completely taken back to stock without too much trouble. So I hope you enjoyed that one. It's the first time I've ever seen RGB to HDMI in person, although as I say, I appreciate this isn't the standard RGB to HDMI. And a couple of people I've been talking to have been absolutely raving for months on end about GTIA Digitizer. So it's been nice to experience both devices simultaneously, although I would like to maybe get hold of a stock RGB to HDMI and try it with stuff like VBXE machines. That would be quite fun, and see what it's capable of doing. If there's something I didn't try here, or as I say, if you know more about this device than I do and I've done something wrong, or I've misspoken about its capabilities, please chime in the comments. I'd love to hear from you. But other than that, this machine is now done, so there's another one I can send off. If any of you have been keeping up with the work backlog here, I've pretty much got on top of it now. I've still got a box of stuff from the Netherlands, which is kind of an open-ended sort of, it's half up to me what we do with the machines and what we put in them kind of project. I've got an Amiga 600 repair that I'm halfway through filming. I'm waiting on some parts from China to get that one done. I've got an Atari ST to fix. I've got one that's just arrived. I've got a 130XE that's waiting for some retro brighting. But we've got the whole thing down to manageable proportions now. I'm pretty much on top of it, and I'm so much on top of it now that I'm even thinking about doing some coding again, which is desperately needed. So, of course, as always, thank you to my generous patrons for their support. Thank you to the video sponsor, of course, as well. And thank you to everybody who's watching the videos and interacting with them, sharing them, liking them, and leaving their comments as well. With that, I'll bring this one to a close and probably get on with the next one pretty much straight away. And so thanks very much for watching. I do hope you enjoyed it. And as I say, if you've got comments, please leave them down below. And I will see you in the next video. So bye-bye for now.